So, all right, let me ask you something. Who of you harbors a little worry about AI? Just a tiny little bit. I see a few hands rising up there. Yeah, getting more. Okay, so I know this is a room full of AI enthusiasts, but even in a room of nerds and tech optimists, I think there's always a little bit of concern, right? And to help us navigate all the different kinds of worry around AI, we have the perfect speaker. He's the co-founder and CEO of Lattice-Flow, a company that builds robust and trustworthy AI at scale. Please welcome our next keynote speaker, Petar Tsankov.
All right, so thanks Helga for the kind introduction. Hi everyone, really happy to be here. I'll continue on the thread of the last speaker, so kind of reality versus hype, but really focusing on the risks of AI. And my point is to kind of explain what does it take to make AI safe and trustworthy, focusing on two key points. So how to worry about the right things, that's very, very key. And second, I also want to highlight how is Switzerland having an impact into solving these challenges. So on my part, actually my journey in AI took me to Switzerland. So I did my PhD at ETH Zurich, focusing on the computer science and AI. And I was very fortunate to work with very smart people, Professor Martin Betchev, and ended up building the first systems for safety verification of modern AI systems. And then following this, I created two companies. One of them I sold to PwC Switzerland, just around the corner here. And the second one, Lattice-Flow AI, became the #1 Swiss AI company for 2022. Now, my journey so far has been kind of teaching me how new technology always tends to be very, very brittle in the early days. And it's very important to not get confusion, because if we're confused and worry about the wrong things, the wrong risks about new technology, this can be very confusing because it distracts us from kind of focusing and solving the real problem, the real problems with a particular technology. And unfortunately, this is what has been happening with AI in the last 12, 18 months. And we really have to change this, and we have to change it now, because the AI revolution really is happening right now, okay? So it's been ongoing very, very actively. So, and we've seen this adoption of this technology at scale we have never witnessed before. So again, some numbers, so it took Netflix 3.5 years to get to 1 million users. ChatGPT got there in 5 days, 1 month after it surpassed, I believe, 100 million active users on the platform. So very, very fast growth. And beyond this kind of scale and adoption of the technology, just also let's have a look at the speed at which we have been improving this technology. So if we wanted to generate the best possible video with AI about 1.5 years ago, that's what we get. So Will Smith trying to eat spaghetti, I think we can all agree this is fake. That doesn't look quite real. And if we fast forward now to today, and we ask the best possible, this is Sora, the Sora model, asking it to generate a video of a spaceman and his spaceship, that's what you get, okay? So this is really just a couple of months of progress to make this very fast and impressive progress. So the challenge here is now, just imagine and think about, this is really exponential progress. So think about this continuing in the next 12 months, 24 months, like 5 years, 10 years. So this can really go very quickly, go very far. And I think that's why we're all here, because we're excited about where this future can take us by advancing this technology. But this can also get a little bit scary of, what would this future look like? So how many of you are maybe a little bit worried about if we continue this, like how far we will get in the next 5 to 10 years? I thought Helga asked the question, but I didn't see the hands. Not so many people. Well, that's good. So I think more people should worry. I'll tell you why you should worry. Yeah. So many people worry, and if you open the news and kind of look at what do people actually worry about. So that again goes into risk and what are we really concerned about. These are some of the headlines that would show up if you go on the news, and that's a bit concerning. So because this talks about really existential fears, like what if AI gets so powerful that it becomes smarter than us, and it basically destroys humanity, like worst case scenarios. Very common also problem, job replacement. So what if AI gets so powerful, it can do everything we can do today, and there's like a handful of corporations that controls and does all the work around the world. Now, these are kind of very scary worries, but the point I want to make here is that these are not new worries at all, okay? So we have always, these are very human fears. We have always been worried about these problems ever since we started working on AI, and that has been ongoing for more than 50 years now. Now, to show you and to prove you this, well, this is Life magazine in the 1970s. Just look at this quote by Marvin Minsky. He's saying that he was running the AI labs at MIT, and he would say that within a couple of months, AI would become so powerful that it will reach genius levels, and a few months afterwards, its powers will be incalculable. Okay, 1970. Let's go to 1980s, New York Times. People worrying again about the same problems, job replacement. What if robots and AI become so advanced that they take over all our jobs? Okay, same worries. Not much progress has happened back since then. And the point that we have to differentiate here, that's important, is that all these scary fears, they can become true only once we get to really building a super intelligent, artificial general intelligence. Okay, that's a different kind of AI that is very different from the kind of AI that we're currently developing. So just go there, we talk to the people, developing these models and applications for real applications. So this is different kind of AI, and we have to differentiate these two worlds. I'm not saying that these AGI fears are in general unfounded. I think these things can happen in the future as we make progress. But they are the wrong things we should be focusing on right now, because it's distracting. That's not the current problem. We need to be worrying about this. Now, to help you appreciate my perspective, so I want to go through kind of a very brief history lesson around how has AI developed over the last 50 years, so you can understand why we're not quite there yet, and it's not quite clear how close we would get to really building an AGI. So, history lesson. So, 1956, this is also Marvin Minsky, few of his colleagues, and this is a picture from the first ever workshop on AI. Okay? And ever since this point, so we've been thinking about, the researchers have been thinking about how can we build more intelligent machines. So that has been the core topic. So many things have been tried, but I would like to highlight two concrete approaches that stand out, like two generations of AI that have been successfully developed and applied also for solving real-world problems around us. One of those approaches is symbolic AI, so it's the first generation of AI. And the key idea here was that, kind of the key push was that we can build intelligent machines by relying on symbols, logic, and kind of defining rules that describe the world around us, and then given facts around the world, we can conclude more facts about the world. So, very simple example, if we know that, we can define a rule that says that all cats are mammals, simple, and then if we know that our friend Leo is a cat, we can also conclude that Leo must be a mammal, okay? Now, this worked very, very well, don't get me wrong. In fact, this is still symbolic AI is heavily used in the industry. Like if you think of the complex security protocols, for example, we do use symbolic AI to make sure they work correctly, because these are very complex systems, and we have to really try out all the possible ways attackers can break them. And symbolic AI is very, very strong at this logical reasoning to tackle these challenging problems. The main challenge and where this did not work is really scale. So how do you get to kind of define these bunch of rules to handle complex tasks that work on vision, on video, on text? Just think about, defining a bunch of rules to recognize a cat on an image. We tried to do this, it didn't work. So scale was here a fundamental challenge that kind of imposed the limit on how far we can push this approach of building more intelligent machines. So following this first generation, we got to deep learning. And deep learning then really solved this problem of scale. So the idea here is different. So the idea was that instead of writing these rules, we're going to take a bunch of data samples, like images, text, and so on, and then we're going to train the machine to learn the rules itself. So we would learn how to recognize patterns and solve complex tasks on recognizing objects on an image, generating text, and so on. And this scale worked so well, so it was really surprising that what kind of advanced AI models you can build on top of this. And all the modern models, the large language models, large vision models, are really now focusing and have been based on the second generation approach of AI. But where this falls short is reasoning. So I'm sure that many of you have tried these language models. Many of you have seen the simple mistakes that they can make. And that's because these models, they do have this fundamental limit of just not being able to reason logically, unlike first generation AI. Again, these are fundamental challenges, meaning that no matter how much data we put on this, in training these models, no matter how big and many parameters how big we make these models, these are fundamental challenges that put some limits on how far we can push this technology. So that's important to recognize here. Now, and this is really where we are at right now. So we've had these two successful generations of AI. They are useful. They have fundamental limitations. Even if we figure out somehow how to magically combine these two worlds, meaning that we can build models that would scale, we can train on large data sets and can reason about, we would still not get to building really an AGI. There's more fundamental challenges that we need to solve. Like, how do you, for instance, teach machines basic facts about the world, like the laws of physics? How do you handle memory? How do you handle complex planning tasks? So these are very, very hard problems, and we don't really understand how to solve them today. And therefore, there is no meaningful timeline on when we would solve them so that we can actually get to building an AGI. So we're not quite there yet. That's my key point. And therefore, that's why we should not be super concerned about these hypothetical futures, risks of extinction, superhumans, and so on. Now that I told you not to worry about this, I want to tell you about what we should worry about, because we should not stop worrying about things. That's good. And the reason we should not stop worrying about AI is that AI is already everywhere around us. So again, just go across this room here and look at all the amazing projects that are being developed around us. So we use it in cars, medical diagnostics, generating media, many applications around us. And there are some very, very real risks and concerns that we really need to worry about right now, not sometimes in the future, but really right now. So that's again my point, what we need to be really focusing on. One of these, and I'll highlight three concrete problems that are very real and very, very important to focus on currently, right now. One of them is the issue of bias. I'm sure many of you have heard about this. Key challenge here is that real world is biased. Because of this, data sets are biased. We're training these models on these real biased data sets, and they reinforce these biases. And this has been ongoing for many years now. So this is one famous example with Amazon that tried to automate the recruiting process. And that got very quickly out of hand because for certain male-dominant positions, this just didn't work out. So the models got very, very biased. And they had to shut down this program because it was very hard. It's quite difficult to get rid of these historical biases that we have in the data. So I think we would all agree that we want to have a fair world where these biases are eliminated from these models so we don't continue reinforcing them. So that's one of the challenges. The second one that has been also very kind of prominently visible in the news is the big challenge of misinformation. As you saw earlier, like how fast technology advances in generating content. So today we're very close to generating content that is practically impossible to differentiate from real content. And this is very dangerous. Just have a look at this is the case of the last elections in Slovakia, where somebody generated a fake audio pretending that's the leader of the Liberal Party speaking and claiming that they have rigged the elections. This video goes online just 3 days before election day, and this party ends up losing the vote by a very small margin. So again, this is a very, very real problem that really needs to be serving as a wake-up call for everybody. And we see this happening and also in other elections that have been happening around the world. So very real problem that really needs to be addressed right now. The third problem that I also really worry about is the general problem of accuracy and reliability of this technology. So Still, even today, it's very hard to build AI models that are working very well and reliably and accurately on real-world data. So we can all know how to train very impressive demos that give very good and nice results on our test data sets. But once we deploy it in the real world, things are very different. So if you just look back at COVID times and some of the articles around this, so researchers back then built hundreds of different models claiming amazing results on how accurately they can detect COVID. 0 of these models were actually able to perform accurately when you deploy them and use them on real-world data sets, on real X-ray images. So that's a big challenge we need to solve if we are to use this technology in real-world mission-critical applications like cars, medical diagnostics, and so on. Now, the reason we need to worry about these problems is that we can actually solve them. Okay, so they're not so far away as the AGI. These are things that if we focus about them, we can make a lot of progress, and a lot of research has indeed been focused on addressing these specific challenges. We have solved similar problems in the past. Again, new technology always tends to be very brittle in the early days. Think about the internet. We didn't even have secure protocols. Now we all access our bank accounts securely without anybody's being able to spoof our communication. Software was also not much different really from today's AI. And we again wanted to deploy it in airplanes and many other mission critical applications. And we figured out how to do this. Today we have very robust frameworks on how do we build high quality software. And today it's everywhere, in medical devices, in cars, airplanes, space shuttles, everything. So that's why it's very, very important to solve these problems. And your main everybody's responsibility in making progress here also is that we need to really also be very vocal about this, because even if we solve these problems, a big part of my work has been on addressing these problems, but we also have to make sure everybody around the world cares and actually employs these techniques to building accurate, reliable, unbiased AI applications. And the good thing is that everybody really has been very vocal about these challenges, and this is really giving results today. So, for example, last year, we saw the first ever lawsuit because of biased recruiting software. So one of you complained that this software was biased, and then sued this company. And now everybody building similar software is aware about these cases and very worried about to make sure that you don't ship just quickly software that may have these biases that you haven't checked in advance. I think many of you maybe remember this case as well. So Google, when it lost 100 billion in valuation because of a simple chatbot mistake. So challenge here was, again, there were imposed biases that were not well communicated to the public, and everybody jumped. How can we, why is this not communicated properly? And there was a big mismatch in expectation of the users and what actually the model did. And trust me, everybody today releasing these models really worries about not repeating these kind of mistakes. And because of all these complaints and big visibility around the issues, today really AI trust has become the #1 priority worldwide. So there has been so many initiatives around the world, in US, in Europe, in Singapore, in Asia, around building regulations and frameworks that would impose and ensure that we are putting enough rigor before we actually deploy these applications in the real world. There's literally hundreds of AI standards. Just ISO alone has more than 25 standards about data quality, fairness, robustness of the models. So this is all happening right now. And not surprisingly, Gartner also put AI trust as the #1 strategic technology trend that we need to address right now, which is very, very positive. And it is an outcome of just everybody being very vocal about these challenges. Now, it's good that these things exist. The challenge is, well, how do you actually apply them? So I don't know how many of you have read the EU AI Act and what does it talk about? Few of you. So it's a law, it's a legal document, but it talks about very, very technical topics. It talks about performance, it talks about fairness, about bias in the models. These are not things you can do by just going through a set of questions and asking your AI developers if they're, satisfy these properties. So the main challenge that we see right now is that there's even though we do have these standards and regulation, there's a very big gap between what is set in these standards and regulations versus what is happening really on the technical side. So technical side meaning this is where the data science world is, creating data sets, training the models, and so on. So there is a big gap. They're done kind of almost quite independently, I would say. If you look at the EU AI Act, there are things mentioned that are just not even checkable, which is a challenge, because how do you do compliance if you cannot prove and provide evidence that your model satisfies these properties? And you cannot, there's no way you can show compliance and validate this compliance with these standards unless you kind of go deep and then validate the data sets in the model. So that's currently where we're sitting as a key challenge, which we have to address. So what does Switzerland has to do with this? Well, in Switzerland, actually, we have been conducted one of the first AI assessments where some of these standards have been applied for real-world applications, AI applications used in the banks to ensure, to mitigate risks and ensure that these models actually are performing well in production. So let me tell you about this. It's a very, very nice success story related also with the ETH AI Center. Actually, Migros Bank came to ETH AI Center and they wanted to use a software called Govago, which is doing car leasing. And the key benefit of why Migros wanted to use this vendor is that they use AI models to very accurately predict what would the price of the cars be in the future, and they do this for car leasing. Now, why is this interesting for Migros Bank? It's interesting because they can make more profit. If I can accurately predict the price in the future, I can make sure that I make more money out of these leasing loans. And you can get much bigger market share because I can give the best terms, car leasing terms on the market, and then they get to, users would buy cars or lease cars from Govago back to my Migros Bank. Now, the challenge, well, this model better works because Migros is putting hundreds of millions of Swiss francs into this vendor. If these predictions of what the prices of the cars will be in the future, if this is wrong, we can end up, Migros may end up losing quite a lot of money. So big challenge, and success story here is that we have been able here in Switzerland to actually address this, and for the first time, really bridge this gap between the high-level AI risk governance layer all the way down to the technical MLOps layer. So very briefly how this worked out in the case of Migros Bank. So the ultimate result is that we wanted to give them kind of a high-level AI risk assessment that they can leverage to get confidence whether they can use this vendor or not. But to get there, you have to start first from, again, the standards, the real datasets and models. Then a key challenge to get to the real assessment was to also formalize, kind of take these high-level standards and formalize what does it mean in terms of real data and model checks that you need to conduct to apply these standards. Then measure those, run these checks so that we can get real results. And then once we get these low-level technical results about the quality of the data and the models, then we can kind of lift this and produce this high-level report that Migros can use. So very nice success story, again, here in Switzerland. Now, going forward, the next good thing that Switzerland is doing is that it's not just about doing this once, but many other banks, many other pharma companies are facing the same kind of challenge. And also now the Swiss government is supporting this project, where the goal will be also to bridge this gap between regulations and the technical layer by building kind of the glue and the platform that automates this process and makes it very, very easy to provide compliance for companies around the world. All right, so in summary, I wanted to highlight again my two key points. So one is, let's really stop worrying about hypothetical fears. Let's really focus on worrying about the real challenges that are right now ahead of us. And by doing this, we can really make progress and ensure that AI will be adopted in a much safer and more reliable way. Right? Thank you very much.
Thank you, Petar, for your insightful presentation. We have time for a few questions here. The microphone is over here. Do we see a hand rising? not yet. So while you're thinking, I have a question for you, Peter. So living in the AI ecosystem for many years now, are you getting more worried with time or less?
I would say, yeah, they're definitely not getting more worried. So again, this is everything that has been happening with AI is very expected, nothing unusual. We have seen this wave of new technology that is brittle and challenging many times. So there's nothing worrying. It's all about just focusing and just solving these core challenges. We can solve them. We have solved many of them, and it's about kind of bringing these solutions to the real world.
Mm-hmm. Yeah. And we see a question over there. Yes, it's there in the second block to the left. Thank you.
Hi everyone, my name is Phil and I'm thinking about creating a startup in the coming years. And what I recognize is that when you're in Europe, there are a lot of regulations that you need to comply with. And I'm wondering, is Europe the right place to start a startup? Or is it better to go to the US where there's less regulation?
Yeah, so in general, I mean, what we saw actually a few weeks ago, there was signed a treaty between the US, UK, and Europe. So there is a major push also to unify the regulations in these regions. So I don't think in general Europe would be in disadvantage. So this is something that has been showing a lot in the news that maybe Europe would go to over-regulate the AI markets. But what we see really happening is that there was kind of a push to unify this, and there would not be disadvantage of being here as opposed to doing this in the US. So I would recommend stay here, build a company here in Switzerland.
Okay, we have another question over here, next to the tech table.
Thanks a lot for the insights and the Swiss Cognitive. You brought this bias example with regards to recruitment, and we have that obviously in all the industries. Where do you see the potential that we are capable and able to unbias the bias by reinforcing the algorithms based on the bias data to get a more accurate result?
Yeah, so in terms of bias, so we can solve for specific. What is the challenge of bias? If we know what kind of bias we don't want to have, we can make sure that the models are not biased with respect to specific biases that exists today. The big challenge with AI right now is there's also many hidden biases that we don't know about, and these biases often also impacts how accurately models are working in the real world. So really the challenge is around uncovering the hidden biases in the models that we didn't think about, but for the ones that we are aware of and we want to eliminate, that's something that we can, there are very reasonable approaches to apply and solve this problem.
Do we have one more question? Yes, over here.
Petar is my name. These technologies are driven heavily by data. That's why after 70 years, this hype is popping up these years. The data sits in the companies mostly. Research is not that strong in that way. And we need regulation, and regulation is also coming. But as you very well have shown, that there is a gap, the certification part. What is your vision? The certifications compared to other safety critical sectors like nuclear, aviation, or aerospace. Where will these certifications be carried by organizations, by standards organizations? What you've shown is rather a company. Mm-hmm. What is your vision in this?
Yeah, so very good point. So if you talk about certification and relative to other certifications in other domains, so this is not much different. One difference that we see with, for example, the EU AI Act, that it's much more technical on how do you provide compliance as opposed to, let's say, GDPR, where it's more about looking at processes, so it's more of a high-level compliance assessments. So this is very technical level assessment. In terms of like who do you actually does this and who is policing this, so this is yet to be defined for the EU AI Act. What we see is companies are themselves right now internally very worried about risk mitigation. Like we see Migros Bank, there's many other banks and pharma companies in Switzerland that worry about this. So they're doing it internally, and they're not worrying yet about compliance with regulations because they're not yet enforced. They're enforced, but there's a compliance window, so they're not being fined right now. So they are kind of internally just making sure that things are working, so they don't have business impact due to misbehaving AI. But going forward, this would be carried out by certification companies, the standard ones that would be issuing certificates. So any product that has a CE stamp and has AI would go through this kind of certification. And what companies can do, like Lariso, is building the products that actually enable this certification. Because you do need to get technical evidence that supports compliance. And this is, again, technical. It's not something you can do by talking to people and asking questions.
Thank you, Petar, for sharing your thoughts and insights, your expertise in the field of safe and trustworthy AI made in Europe. Let's give him a warm applause again. Thank you.